Hello everyone. Today I'm going to talk about my Physics2212 lab 4 circuits. So the purpose of this lab is to use the principles of energy, loop rule, and current conservation to predict the behavior of circuits with resistors in series and parallel. Use multimeters to measure the actual values of conventional current and potential differences in the circuits and examine behavior of ohmic resistors and capacitors. So for a quick overview of results, I found out that a current I1 and current I2 was equal to each other, which was 0.02 ampere, and my RC was found to be 6.8 seconds. Now I will talk about the basic physics principles required for this lab. So first of all, we need to understand the Ohm's law, energy conservation, which is loop rule, the node rule, potential difference of a capacitor, RC circuit equation, equivalent resistance in series, and also need understanding of batteries, resistors, and capacitors when charging and discharging. First part of the lab. So for the first part of the lab, we need to consider a series circuit of two 1.5 volt batteries, two resistors in series, 2 ammeters, and predict the I1 and I2 that would be measured by the 2 ammeters. The system during the experiment was circuit and the component connected with wires. The surrounding was everything else in the lab room. So I used loop rule and Ohm's law to find the current I1 and I2, which are found to be equal to each other. So next, I'm going to talk about how I actually got the value of 0.02 amperes. So for detailed steps of how I got 0.02 ampere for current, I applied loop rule as indicated by my notability note from iPad. So over here, we can use the loop rule, which is delta V loop equals 0. And also note that resistors in series have same current. So we can actually see that 2 times 1.5 volts minus 47I minus 100I is equal to 0. By rearranging the math equation, we can see that 3 equals 147I, and I was found to be 3 over 147, which is equal to 0.02 ampere. So the math checks out. So what if I insert one of the ammeters backward? Nothing changes as indicated by the simulation. Still I1 equals I2, which is equal to 0.02 amperes. So what if I replace one of the ammeters with a voltmeter? The voltage drop across the gap will be negative 3 volts as indicated above. So the voltage drop across battery is positive 3 volts and across the first resistor the voltage drop is negative 0.959. Across second resistor the voltage drop is negative 2 volts. So if we plot the voltage drop, as expected, the plot starts at 0 and ends at 0 volt as expected due to the loop rule. And this is the question. When you attach the voltmeter, you alter the circuit. Why doesn't the ammeter reading change? My answer was that the voltage has a high resistance, so negligible amount of current flows through it. What if we add an ammeter in parallel with the 100 ohm resistor? Since the ammeter has a very low resistance, meaning that most of the current will go through the ammeter instead of the 100 ohm resistor, effectively lowering the total resistance of the circuit to 47 ohms. So by using loop rule, we found out that the I was equal to 0.064 ampere. So the resistance of each circuit element was calculated from Ohm's law. We can see that delta V resistor is equal to IR, and rearranging the equation gives R equals delta V over I. Now I will talk about RC circuit section of the lab. To the right, we have an actual lab picture that I took during the lab. So the left image indicates the discharging and the right image shows charging of the bulb. The bulb connected in series to battery and capacitor took 5 seconds to charge, and also the bulb connected in series to charged capacitor took 5 seconds to discharge. So RC circuit with 20 ohm resistor, the bulb connected in series to battery and capacitor took 10 seconds to charge, and the bulb connected in series to charged capacitor took 10 seconds to discharge. Compared to a 100 ohm resistor, we can see that it took significantly longer for charging and discharging. The slope was found to be negative 0.1468, and according to lab instruction, negative 1 over RC is equal to slope, and by rearranging the equation, RC was found to be 6.8 seconds. These are my what if questions. So the real ammeter wouldn't display 0 ohm for the resistance, and a real ammeter would contribute to the total resistance in the circuit, and overall current would be lower than the simulated.